Banjo Biyami. I'm a developer advocate at AWS.
Hi, I'm Olivier. I'm also a developer advocate at AWS.
And today we're going to walk through building an AWS Solutions Architect agent using Amazon Bedrock. So I want to set the stage about the builder landscape is how we see it. We think of the more further left, more expertise is needed. So you can think of ML infrastructure like AWS Trainium, which is making training from large models, inferentia, so a hardware chip to actually do the inference that these models use. This is on the hardware stack. If you move one more layer up, you think of ML services. So this is Amazon SageMaker. So these are practitioners that are fine-tuning models. They are using frameworks like PyTorch or TensorFlow to do deep customizations with models. You move one layer up the stack, we look at AI services like Amazon Bedrock. This is a serverless API that you access the foundation model, you send a text, you get a result back like an image or other text. And move one up more layer, you have AI applications. So think of Alexa, we can just say something and it will just respond to you or do some type of thing, or something like Q that we announced today, which is a chatbot that can help you. For this talk, we'll be focused on the AI services. This is really where builders such as yourselves can start really expanding and playing around with things, and really how we can power agent-based applications. I like this quote from Sean about saying agents are the hello world of the AI engineer. Anyone that's been playing around with large language models, they want to make an agent. Maybe I wanted to chat with my documents or take some type of action. So we're going to walk through exactly what an agent is and how we can actually build it using Amazon Bedrock. So what is an AI agent? I like to think of it as an application powered by a large language model for a predefined system prompt, which are custom instructions on telling it how to act. These agents also had a set of tools which are self-contained functions to perform a specific task. So think of it as a task as like deploy a Lambda function or generate an AWS diagram. So agents, we allow general availability today. So basically, it's going to allow you to make these new type of functionality for your customers to build new experiences. And we're going to walk through how that actually works. So for this talk, we're going to walk through some of the common tools people use to build agents. I'm going to define what our solutions architect agent is going to do, how you would set up the agent to begin with, how do you build tools for this agent, and then putting it all together. So first, let's dive into some of the tools that we're going to go over today. So Streamlit is a framework for Python developers that allow you to make interactive web applications without needing to know HTML, JavaScript, CSS. It's all in pure Python. So the Python developer, this has been amazing for demoing applications, building things out without having to learn like React or JavaScript. So this has been very great for Python developers to build something. LangChain, so if you've worked with large language models, you've probably have seen LangChain. It provides a set of APIs to do many common tasks, such as scraping text and storing data in a vector database, calling different foundation models. So it's very essential for a developer to understand how to use tools like LangChain to integrate with other large language model applications. It's also Amazon Code Whisperer. So this is a coding companion. So if you ever type comments like write code that can do X, Y, Z, Code Whisperer is able to do that and follow instructions and really help you stay in your flow state directly in your IDE. Amazon, we ran an internal study, and we saw 57% of the people that use Code Whisperer finished faster, and the 27% were more likely to succeed with the task. So Code Whisperer has really enabled developers to build and focus on creating cool things for their customers. So let's talk about our solutions architect agent. So I mentioned agents have a system prompt. So for this agent that we're calling Agent AWS, you are an expert AWS certified solution architect. Your role is to help customers understand best practices for building on AWS. And you have tools that can help your customers with knowledge. So querying the AWS architecture framework, writing code and deploying code, and also creating AWS architecture diagrams. So when you look at an agent, the framework is that we have a Lambda function that's able to actually take all those tools that we defined And then we have a specification in an S3 bucket that can tell the agent what tools it has access to. And then the user can actually ask questions and it will get information back. So this is the framework that we're going to be walking through today and showing how you can connect all these tools, build the tools independently, add them to a Lambda function, and then give the agent ideas on how to use these tools, and then ask it to ask questions to it and is able to respond and use the right tool for the right job. So first, let's start about how do you actually start building with an agent. And Olivia will take it away.
Okay, we're going to do some demo now to show you how to build an agent on AWS with Bedrock. Right, cool. So let's go to the console. You all know the AWS console, I hope. So this is the IAM console, to the Identity Access Management console. So I'm going to walk you through this, also the creation of the role, so you can see, because there is some key things you have to know on this. So first things we want to do when we create an agent, we want to create a role because we need this agent to have a role. So I'm going to go to my IAM here. And I want to show you this because the role name, you will see that he has to have a defined pattern in the name. So I'm going to create a custom trust policy, and I'm going to say, okay, it's a service, and it's for Bedrock. Okay. And this is important. What is important here, I want to give it some permissions here. So I've created some policies already, because how an agent works is that the agent is actually going to call Bedrock. So when you call an agent, it doesn't reply directly. It's going to call Bedrock also. You don't call Bedrock directly. So you need to give access to Bedrock to your agent. So I'm giving access to invoke a model here. And this is why it is important. In order to your agent to have a role, the role name has to look like this: Amazon Bedrock execution role for agents _. It has to start like this. And then you put whatever you want. Let's put reinvent, for example. So this is my role, I create a role, and I'm done. Now, I have my role, so let's go to Bedrock. That's the important part, right? We want to create our agent. So this is the Bedrock console, and here I'm going to go to Agents, and very easy, I click on the Create Agent button here. I'm going to give it a name, Agent AWS. I'm going to give it a description too. This, well, actually it needs to no space. Here, user input, it tells you if you don't give information, it can ask you more questions, so you can give more information. So let's keep that to true. And then that's the IAM permission that I just created. And you see, it only lists the one that has the pattern that starts with the Amazon Bedrock execution role for agents _. So I have it here, selecting it, and just leave that by default values, and next. So here, in the model, you have to select which model you want to use for your agent. So let's keep Anthropic for this one, and you have access to all the models here. So Claude V2, Claude Instant V1. Let's use Claude Instant V1. And then you're going to give some instruction for your model. And what it is kind of what Benjo mentioned. You're going to say, like, you are an expert AWS certified solution architect. Your role is to help customers understand best practices on building on AWS. And I'm also saying, you will provide links to documentation to support your answers when you have them, so you make sure that it doesn't hallucinate. And basically, this phrase is going to be sent every time I ask something to the agent. Like before my prompt, it will send that before, so it knows the context of my query. Next, action group will come to that later. Analyze database, that's for later too. And now just create my agent. So when you create an agent, you have the opportunity directly in the console to talk to it. So here I have a chat, so I can just ask a question. How can I design secure VPCs, for example? And so what is happening here, that the agent is calling Bedrock, and it doesn't know the answer. That's the point. Otherwise, the talk is done, right? So what we want to do is we want it to be able to answer these kind of questions. So how do we do that? Well, for this talk and this demo, we're going to use the well-architected framework. If you are not familiar with it, it's a set of good practices that you can find on the AWS website. And basically, it's how we encourage you to build architecture. And what is interesting is that you have these sitemaps here. So we have a set of files with all the links of all the documentation of the well-architected framework. So if I go in my code, so we did a tool. We built a tool to ingest all of these pages. So here we have a list of all the XML, and if you look at the XML, basically, if you want to see, I just take one, I open it, and this is the documentation. So we take all of these XML, which each one of them has lots of HTML links, and we're just going to go through them, and we're going to load the HTML text from it, and then, where is it called? And then we're going to call the embed text method here. And basically what we're doing is that we take all the text from these pages, we cut it in small pieces of text, and then we put them in a vector database. So here we're just saving the database locally, so we're going to use LongChain, as Benjo mentioned. So we have this, from document here, we're taking all the chunks we created from the text from all the pages, and then in the end we save the local database. So it's here, it's in my local indexed folder here. So here I have a vector database stored locally. All right, and then once we have that, when we need to call it. So I have this tool here, basically. So now we have ingested all the well-architected framework, right? So if I want to call it, I have this method here, AWS well-architected tool. And what I'm doing is that I'm using Bedrock embeddings, which I use already to save the vector database. I'm loading the database I just created here, and then I'm going to use this method called similarity search. So I'm not going to go into details on how vector database work, but basically just transform your text into numbers, and then it finds what has the closest meaning with your prompt, and then it gives you the answer. So I'm going to use this similarity search with microarray. So microarray would be like, how can I design secure VPCs? And then I get some results. And for each results, I get the content of the similarity, and I get the source, meaning the web page where it comes from. And so what I do is that, I just don't send that back to the user. What I do with that is that I create a new prompt. So I'm going to use a new prompt, create a new prompt which says, use the following pieces of context to answer the question at the end. And I give the context, which comes from the vector database. And I put my question again, how do I design secure VPCs? And then I call Titan. So Titan is a LLM designed created by AWS. It's like we use Claude V2 for the agent, but on my code I use Titan. So I just call another LLM with the prompt I just designed. And then I just send the response back with the generated text and the links of the source where it comes from. Right, okay, so let's very briefly try. So I have this here, just calling the well-architected tool that I just created with my prompt, which is, how can I design secure VPCs? And normally, if everything works, it was working 5 minutes ago. I have an answer that says, okay, this is what you should do, apply multiple controls, blah, 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 with links to the well-architected framework. So it's using the links of the documents that I've added to my vector database. All right. I think it's good already for the well-architected framework, right?
Yeah.
To some slides?
Yeah, we can go on, yeah.
Cool, thanks.
Pretty cool that you were able to embed all that text and then show an answer. So if we had like a Streamlit application, we can do the same type of thing that will just say, have a user ask something, we'll get the response and have the links together. So tools are versatile because you can embed them in other different locations. So I like to be able to create that tool, then depending on the construct, I can add the tool to different type of applications. And we did this locally. So we also have AWS Knowledge Base, which allows general availability today, which is a managed RAG service. So instead of having to store them locally, like in that pickle file that we had, we can use a knowledge base. You can actually pick which vector database you want to use. We have, you can use OpenSearch, serverless. We have Pinecone, and you can use Redis Enterprise Cloud. So this gives you, depending on your use case and what you're more familiar with, you can have the vector database managed that way instead of just locally. And to look through how the vector database works, when a user asks that, the embedding model is going to actually do that on the fly. So we had the code that we showed that we were doing that embedding. The knowledge base handles all of that for you. So you don't have to write any other code. You just upload your documentation, and then we do the entire workflow that we just demonstrated there. And what's cool about agents is that, so you saw how we listed each of those documents by themselves. With agents, it actually puts like sources there, so you can actually click into them, so you already know where it got that information from. So one of the biggest things with large language models is like hallucinations, or where did it get this information for? So having a service that can embed exactly where it got that information for really earns trust with the customer. So the next tool we're going to talk about is writing code. So large language models are great at writing code, but I wanted to package up the application so we could actually write the code and then even deploy the code. So I'm going to walk through. It's really to automate code based on a user's intent. I'm going to show a quick demo here. Let me. Oops. All right, ready to show the demo? Oh. Cool. All right. So in this tool, I'm going to do a create Lambda function. So how this works is I want the large language model to actually provide the code, the function name, a description, and any external Python libraries. It's very important to put guardrails of what your large language model can do. The more surface space you try to do, the more room for error. So I'm very particular with what I want it to do exactly. So for example, I'm saying it's only going to use Python 3.9. I'm going to say the Lambda function is always called Lambda function.handler. So really, I just want to focus on code and don't give it too much information. I also have an S3 bucket that I also hard-coded to say you're going to use that. So when the large language model writes the code, it's going to package up the code into a zip file. It's going to upload that to an S3 bucket. I'm going to then use the BOA3 function to actually create a Lambda function and push that to my AWS account. I also have a role I predefined. So I'm providing a lot of infrastructure to allow the large language model to do what it's good at, writing code, and then I'm providing a pathway to just automate a lot of the boilerplate things, such as actually deploying it. So let's see how that looks. So in this example, let's see the code while that's running. I asked the agent, can you deploy a Lambda function that can generate a random number between 1 and 3,000? And let's see what it does. So say, how can I deploy a Lambda function and generate the number? It understands that intent. It's using this create Lambda function tool that I developed. It puts the code in. If it's just an import random and then run a random number generator. Gives it the function name, the description. It has no external dependencies. It's able to run the BOA3 command, deploy it, and then it returns back the information of how I was able to do that. It tells me I need permissions, et cetera. And if I go to my AWS account, it should be there. Refresh this. And yeah, random number generator. So there's the code. And again, very simple function, but I provided the infrastructure that allowed the model to understand how to do that and take action directly into my AWS account. So it really opens up a lot of different use cases. Imagine being able to deploy things without even having to go to the console or CDK or anything, just interfacing with a chat bot and using a tool. So that's really the type of use cases we're really excited about.
Do you guys have a way to version control the infrastructure that you just deployed?
Yeah, so the question was about, do I have a way of version control this? So you saw all the helper code I did, so it's really up to the builder to decide how you want to do this. So, I mean, I'm just providing what I want from the model is the code, the function name, the description, and any external libraries, and I'm deploying all this helper code. So it's really up to you. You can add a git something or code commit, so it's really up to the builder to decide how to do that. You just provide the infrastructure you need for your model to do something. All right, and let me go back to the next tool I want to talk about. So the next tool we talked about was actually creating diagrams. So this tool, given a user query, we're going to actually show a diagram based on what the user asked for. And I'm going to use a fine-tuned model to help me do this. So a fine-tuned model is able to understand the library I'm going to use, the diagrams library, and understand the intricacies of how to actually call that to actually generate diagrams instead of just using the base model. So, for example, if I ask like the base Claude 2 model, write a function in Python using the diagram library to draw a diagram that shows an S3 bucket, connect an EC2 instance, it gives me a bunch of code that looks right, but when I actually run that code, this is no fine-tuned, I get an error. So it just hallucinated a bunch of code. It didn't actually know that. It just assumed this was the best way. So regular model is not going to understand that. So I need to create my own custom model to understand the intricacies of the diagrams library. So it's very important to know when to fine-tune because fine-tuning is expensive. So you need to have the specific data for that use case. It's very domain-specific. You're not going to fine-tune something if you want to, if it's a very basic type of question or something you can use with retrieval augmented generation, which we just demoed. And again, it's very expensive to fine-tune, so but let's walk through how you would do that just based on your use case. So for this model, I was actually able to fine-tune just using a bunch of examples, around 20 to 50 examples. So for this, I had 37 examples. And it's just input peer and then the actual code. So I can say a diagram that shows an S3 bucket, and I actually wrote the code that actually would show that. And I have about 37 examples in this JSON file that just different type of things. It could be RDS instance, EC2, combinations of that. So I need to give high quality examples for my model to be able to follow. And from there, with Bedrock, you can select hyperparameter tunings. It's good to just go with the defaults at first to kind of see what your model is doing. Epochs are how long the data set's going to be training for, the batch size, learning rate, how much the model changes, and then warm-up steps. There are already smart defaults there, so it's good to just start with that. But if you want to get more specific, you can tune those parameters to meet your use case. So I was able to just use the regular models, and then we have a loss curve after when your model starts to train. So initially it starts pretty high, so the model was not learning, but as the model is training, you see that the loss curve sharply decline, and then it starts to plateau. So that's when you know that the model is probably not going to get any better. Let's try it out. So lower is better for the loss curve. And training jobs can take a few hours. So after that, I was able to use the fine-tuned model. So I did the same type of function, and then I'm able to actually get a result. And I can demo some of that just so we can see how fine-tuning actually looks like. So let's go to the demo.
Let's use the demo, please.
Yeah, so this is my JSON file with all the different examples of the fine-tuned model. If I go to the Bedrock console, we can actually see what it takes to fine-tune. So when I said fine-tuning is expensive, you have to be very sure you want to do fine-tune. So this, I'll just show you the cost of what it would be to fine-tune a model if we try to fine-tune something. You have to purchase a model unit. There's no commitment for some of these models, but even if I put no commitment, it can be $20 an hour or $492 a daily cost. So you have to be very sure you want to fine-tune. You can try something out, see it is, but fine-tuning is not the first thing to do. It's only a very specific domain use case that fine-tuning can help. So let's keep that in mind. But yes, I can, once the model is fine-tuned, I can actually run some examples. So I have some example queries. And you can, let's start the, have another Handley Streamlit application. We can just put a query. Yeah, so it's able to generate the diagram. So my specific use case would have very specific domain knowledge that I need to embed in a model, and so I can understand that's when fine-tuning can be very helpful. And
all right, I'm taking over. So we've seen how to, ask an agent to, how to create an agent on AWS on the console. We've seen how to create code to, to ingest the well-architected framework to then give us back some information on how to do things. We saw how to generate code. We saw how to generate diagrams. So it's cool, but all these works locally, right? But we want it now. We want our agent that didn't work before. We want it to answer all these questions. OK, can we go back to demo, please? So here, I have the code that I was showing you. Nope. Yeah. Here is the code that I was showing you. And what I did, I just created a Lambda that is going to call the different methods. So we have one to call the well-architected framework, one to generate the code, and one to generate the diagram somewhere. Anyway, so how this works is that my agent, it needs to know which API it has to call if I deploy a Lambda. And to do that, we use the Open API. I don't know if you're familiar with Open API. So basically, Open API is a specification that defines a standard language, a specific interface for HTTP APIs, both for machines and humans, to discover and understand the capabilities of a service or an API. And I have one here. So this is what it looks like. So basically, for every API endpoint, like query well-architected framework, gen code, I have a set of information, and that's the information that my agent is going to use. So when it detects that I'm asking, how do I design secure VPCs, it will know that this is the query well-architected framework. It's smart enough to know which API it has to call. OK, so let's see how we can put all of this in Bedrock. So the first thing I want to do, I want to do my Lambda. So I'm going to create a function. So the code I have here, I've already packaged it as an image on ECR. So I'm just going to use a container image. I'm going to call it like a Bedrock SA tools. I'm going to select the image here. So the Bedrock SA tools image is literally the code I showed you earlier, packaged, including the vector database that we generated, so the local database file. So I'm using that to create my image, and I create my function. So now I need to give some permissions to my function once it's created. So create my function. So first thing I want to do, first thing I want to do, we're going to do some AI, right? So let's first start by editing the general information. So I want to take more memory for my function, and especially the timeout, because 3 seconds, it's a bit short for an LLM. I don't know if you've called LLMs before, but 3 seconds is too short. So let's put like a 3-minute timeout just to make sure that we're safe. And then I need to give it some permissions. So I'm going to go to the role that have been created by Lambda. And so in my Lambda, so Benjo is calling Claude to generate code. I'm calling Titan to call with the generated prompt. I'm going to call Titan embedded too. So let's add some permissions here on my existing Lambda. So I'm going to edit that. So I'm sure that my Lambda can call all of these Bedrock models. So service Bedrock. I want to invoke model because that's the only thing we're actually asking it to do. And I'm going to add some
Invoke agent or invoke model?
Oh, yeah, invoke model. Good point. Thank you. And here, so again, I don't remember the regions we're using, so let's just put any region. Don't do that at home. And then, so I'm going to call Titan embedded text that we saw earlier. It's also calling Titan light. So these are the models that I'm querying in the code we wrote earlier. So here, and the Claude V2 for the code generation. All right? So now I'm all set to go to my agent again. So when you're in your agent, if you remember, here, I have all these information. I have this working draft. So the working draft is the current version of my agent. So I'm going to edit it. So every working draft can have like a different prompt. For example, like instructions here is the one we did earlier. You are an expert AWS certified solution architect. So let's go there and add an action group. So when I add an action group here, I have to give it a name. I have to give it a description, which is optional, so let's not do that. And then that's where I'm going to select my Lambda function. So let's select it. And then that's also where you have to specify the Open API JSON file. So I stored mine on a S3 bucket, which remind me that my agent doesn't have access to S3 bucket. So let's go there and edit it. I'm going to add this policy. So I give it access to S3 bucket, so I make sure that it can find the Open API JSON file that I showed you earlier. I'm going to browse, reinvent, and this is the JSON file I showed you earlier. I just put it on an S3 bucket. And I'm going to add that, and if everything works well, so it detected that my agent working draft changed, so it asked me to prepare it, so let's do that. And actually, before that, just to make sure it's not going to break here, I'm going to go to my Lambda function here, and I'm going to test my Lambda function first. So I know it works, so if it doesn't work, maybe it's the agent, maybe it's my Lambda function. So this is a query to my Lambda function with the Open API format here. I'm just sending the, how can I create secure VPCs, just to make sure. I just want to test my Lambda first before I connect it to my agent. So it's going to take a few seconds. That's why we increase the timeout. Otherwise, it just, everything goes red. I don't like red. Red is bad. Green is good. Give me some green. All right. It's complicated to design secure VPCs, apparently.
Details.
Okay, green. Green is good. So it's giving me, VPC network access, blah, 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 with links. Okay, so the Lambda works. Now, I just connected it to my Bedrock agent. So let's see if I ask again, how can I design secure VPCs? And normally, what is happening is that my agent is going to understand the question and detect which API it has to call, which endpoint. And, ooh, all right.
Access denied.
Yeah, I know what I did. So, yeah, my Lambda function here, forgot something. I need to tell Bedrock that it has access to my Lambda function. So here you have to add some resource-based policy statement. I'm just going to say, give a name, and just say bedrock.amazon.aws.com. I'm going to say that I want this Lambda to be able to be called by Bedrock. So I say Bedrock can just, invoke function on my Lambda. All right, now it should work. You know what? Let's refresh stuff just in case. All right, are you ready? Rams. Okay, hopefully it doesn't take 30 seconds like earlier. So same speech detects which API endpoints to call, and hopefully it will tell me everything I need to know about how to design secret VPCs. Here, cool. So it's telling me to design secret VPCs. So sometimes, it's an LLM, so sometimes it's giving me the links, sometimes not, but at least it knows the answer. And you can do the same for the question that Benjo asked earlier, right? A function that uploads the file. So it won't be pretty because it's not a code editor, but okay. Sometimes it works, sometimes it doesn't. But technically, it will detect that this time we ask for code and is going to ask to generate code. So yeah, can we move forward with the slides? Yep. Can we go back? Yeah, sure. Okay, so we saw how to create an agent, how to connect it to a Lambda function, how to ingest data from whatever. We use the web-architected framework, but we can use your FAQ on your company, whatever you want, whatever data you want, that is not in the general model of the language LLMs, and how then we can query this to add some features to it. So we're using this reasoning and acting in language models, so that's what we explained that you send a request, is going to evaluate the request and
basically pick what tool it has
Yeah.
to solve the task at hand. So like query well the framework or write code or write diagrams. So it's not just, the more you give space to model to think, the better the answers are going to be. So this React framework encapsulates that.
The more options it has, yeah, the better it is. So we talked about that already. That was in case the demo didn't work.
And it works.
Showed you the agent. It works.
Yeah.
We have backup.
Yes.
Screenshots.
So to the end, I say Amazon Bedrock democratizes generative AI, enable builders to transform customer experiences. Agents are going to be one of the most important things when it comes to generative AI when you're thinking about how can you help your customers design new experiences, what type of tools you can create. We saw one with a virtual solutions architect that were able to write code, deploy a Lambda function, generate diagrams, and even cite the well-architected framework. And this is just the beginning. There's so much excitement in agents. I'm excited to see what y'all are going to be building. So thank you.
Thank you very much.